Hello, welcome back to the channel. So let's move on to a new concept which is based on solving definite or indefinite integrals using trigonometric functions. So using substitution with trigonometric functions in this case. So in these type of questions, when you have to identify the pattern, you basically have to look for an expression which would look somewhat like a square plus minus b square x square. So whenever you have an expression like this, for example, let's say 3 square plus 4 square x square, 3 square minus 4 square x square. So whenever you see some pattern, for example, in this question as well, you see an x square plus 4 expression over here, which relates to this expression over here, right? If we assume b to be 1 and a to be 2, we can write this expression as simply x square plus 4 as well, right? So whenever you find a pattern which looks somewhat like this expression over here, a square plus minus b square x square, this will probably give you an idea to use substitution with trigonometric functions in order to simplify these type of questions over here. So again, in these type of questions, whenever you see a pattern like this, the correct approach to solve these type of questions is by using these three trigonometric identities over here. So in this case, you basically have to use substitution and convert your a square plus minus b square x square expression such that it would resemble one of these three trigonometric identities over here. Don't worry if that seems complicated. We'll do this example and then it will give you a very detailed idea about how we solve these type of questions whenever we have our integrals of this expression over here. So let's write the integral first. Our integral is basically to calculate 1 upon x square plus 4 to the power 3 by 2 dx in this case, right? So now since we have this pattern over here in our indefinite integral and we know we have to use one of these three trigonometric identities in order to solve for this integral or in order to simplify our integral. So in this case, if we can convert this x square plus 4 expression into just one trigonometric function, we can simplify our integral, right? And the way to do that is we can use these two trigonometric identities over here. If you assume your x to be 2 tan theta in this case, if your x is 2 tan theta, your x square would be 4 tan square theta, right? So then when you'll have 4 tan square theta plus 4, you can use this identity over here, the second identity, since if you have 4 tan square theta plus 1, you can write this as simply 4 secant square theta, right? So that is why in this case, if you'll take your x to be 2 tan theta, you will simply convert this x square plus 4 expression into just one trigonometric function expression over here, right? So let's use that observation. Let's assume our x to be 2 tan theta in this case and see if this simplifies our integral over here or not. So if we assume our x to be 2 tan theta, and now if we calculate the derivative of x with respect to theta, because since this is the kind of substitution that we are doing, right? So since we are converting all the x terms over here, we'll have to change our dx expression as well, right? So that is why we'll have to take the derivative of x with respect to theta. This would be 2, and then the derivative of tan theta is basically secant square theta, right? So this would be 2 secant square theta over here, right? And now if we shift our d theta to the other side, our dx would be simply 2 secant square theta d theta in this case, right? So now let's use all these expressions and simplify our indefinite integral over here. So if we change our integral expression based on all those substitutions, we know that our original integral expression is basically this over here, right? And now we assumed our x to be 2 tan theta. So let's change this x square plus 4 into 2 tan theta whole square plus 4 to the power 3 by 2. And now since our dx is 2 secant square theta d theta, let's convert dx to 2 secant square theta d theta over here, right? So now let's further simplify this integral over here. So we will get, in this case, this would simply be 4 tan square theta plus 4 to the power 3 by 2 times 2 secant square theta d theta, right? And now If we further simplify this expression over here, we can write this as 4 tan square theta plus 1 to the power 3 by 2 again times 2 secant square theta d theta. And now you would be able to clearly see why we chose our x to be 2 tan theta over here, because we know that the tan square x plus 1 equals secant square x, which in this case, since we are dealing with theta, so tan square theta plus 1 is secant square theta, right? And we can simply convert this tan square theta plus 1 into secant square theta over here using the trigonometric identity that we covered in the first half of the video. So this is 1 upon 4 secant square theta to the power 3 by 2, and then this is 2 secant square theta d theta over here, right? And now this would simply be 1 by 4 to the power 3 by 2 times secant square theta to the power 3 by 2 over here, right? And the 2 secant square theta d theta would remain the same. So again, reducing this expression to a simpler form, we will get 1 upon 4 can be written as 2 square, right? So 2 square times 3 by 2, and then secant square theta can be written as secant theta to the whole square. So secant theta to the whole square, and then we have a 3 by 2 term over here as well. And again, the 2 secant square theta d theta is the same. And now when we'll simplify this expression over here, we'll get simply 1 upon 2 cube is 8 times secant theta to the whole cube is secant cube theta, right? Times 2 secant square theta d theta over here, right? And now we can cancel this 2 with this 8, we'll get 4 over here. We can cancel this secant square theta with the secant square theta term in the denominator, right? Which will give us only secant theta term in the denominator. So this would be integral 1 by 4 secant theta d theta over here, and we know that secant theta is basically 1 over cos theta, right? So this would be, and now 1 over secant theta would be cos theta in this case. So the integral will be just calculating 1 by 4 cos theta d theta over here, right? And now we know the integral for cos theta, which is sin theta. So the final answer in this case in terms of theta would be 1 by 4 sin theta plus c in this case. And again, this answer is in terms of theta, but again you would have observed how simple it was to calculate this integral expression over here rather than solving the original integral expression by any other method over here. So that is why whenever you have an expression in terms of a square plus minus b square x square, you basically have to convert your x into a new trigonometric function and use one of these three trigonometric identities in order to simplify your original indefinite integral, just like we did in this question over here when we assumed our x to be 2 tan theta, and then following all those substitution approaches that we already covered in the last videos, we reduced our original integral to just calculating the integral of 1 by 4 cos theta d theta, right? And now since we want the answer, the final answer in terms of x, we know that initially we assumed our x to be 2 tan theta. So x by 2 would be simply tan theta. And now if you have to calculate theta in this case, your theta would be simply, we'll take the arctan on the left side, right? So your theta would be arctan x by 2, or if you like writing those arctan and tan inverse expressions, you can write this as tan inverse x by 2 as well, right? So if you want to convert this answer over here, you'll convert your answer. Your final answer would be 1 by 4. Your sine theta would be sine of tan inverse x by 2, and then plus the constant of integration over here. And then you can further simplify this expression over here, or if you don't want to simplify this expression, you can simply write your final answer as this only, and this would also be considered your correct answer in this question over here. So that's it for this video, and again the main takeaway from this video is whenever you have an expression like this, you will most probably have to use one of these three trigonometric identities in order to simplify your indefinite integrals or the definite integrals given in these type of questions, following the same approach that we did in this video. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.